Great. So, assessing and reviewing research claims is a continuous, central, laborious, and imperfect part of the scientific process. Evaluation types like peer review or replication are each require substantial time and effort and are certainly not immune to questionable research practices. Today, I'm going to be taking you through two specific initiatives at the Center for Open Science that explore innovations in research evaluation that each attempt to address specific concerns of typical research evaluation methods. So to begin, I just want to provide a little context as to what the Center for Open Science is and what we do. We are one of the many organizations with a mission to increase openness, integrity, and reproducibility in research. We pursue our mission on three main fronts, one being research software tools, where we work to maintain the Open Science Framework, which is a project management software that was created to help researchers conduct their research more openly. We also work on community action and culture change, where we train and educate individuals to institutions towards greater adoption of open scholarship practices. And lastly, what we'll be focusing on today, we conduct meta-science research. COS uses research to study the scientific process and test whether certain interventions improve it. We tend to break down our research initiatives into three broad categories, one being assessment, where we clarify a problem, another being norms, where we attempt to foster scholarship, open scholarship norms, and the last being incentives, where we test whether certain interventions are working, how to make them desirable, how are they perceived more generally, and etc. Using these categories, we investigate many different facets of the research process from a more multi-angled approach, such as today's topic of discussion, research evaluation. On the assessment side, looking at research evaluation, we know that current methods of research evaluation have known issues or negative effects on research. On the norm side, we know that items like pre-registration, registered reports, open review, materials sharing, automated assessments, and more are designed to address those concerns. And on the incentive side, we have to ask, how can we evaluate those kinds of interventions and how are they perceived? With that strategy in mind, we'll discuss two specific projects, each investigating two specific innovations in research evaluation, starting with SCORE and SMART and the potential for the use of automated assessments of research material. So, as mentioned, the first focus of this project is the idea that current methods of research evaluation are often quite laborious and time-consuming, and maybe an intervention like automated assessments could help. From 2019 to 2023, the Center for Open Science and our collaborators began our DARPA-funded research program known as SCORE, which stands for Systematizing Confidence in Open Research and Evidence. This program explored the potential for using algorithms to efficiently evaluate research claims at scale. Ideally, algorithms could provide accurate evaluations of research material within minutes, effectively reducing the time and effort required to produce high-quality reviews. The SCORE program first sought to assess how well human evaluators could predict a ground truth measure of credibility, such as a replication outcome, and then assuming that human evaluators could do that task sufficiently well, SCORE then sought to assess how well algorithms could predict human evaluations. The main outcomes from this project included a database of claims from papers, expert and machine estimates of credibility, and evidence of reproducibility, robustness, and replicability that were used to validate those estimates. The sample of research articles was the foundation that permitted all of this work from SCORE to occur. The main sample was called the Common Task Framework, which consisted of 30,000 articles from 62 journals in the social and behavioral sciences that were published from 2009 to 2018. From there, a stratified random sample of around 3,000 papers were selected for additional investigation, where we extracted a single research claim from each paper. So we can just call this the claim extraction set. And then from the claim extraction set, 600 other papers were sampled for even more additional investigation, which in this case, they were subjected to replication and reproduction studies. And this sample set is called the evidence set. So the work that was conducted on the Common Task Framework was split between around 8 primary research teams that were grouped into around 3 main technical areas. One being claims and credibility data, who were responsible for curating the data for the other teams to use. Another being the human predictions team, who were responsible for soliciting human assessments of how likely a claim was to replicate. And lastly, the machine predictions teams, who were responsible for developing machine algorithms to predict the credibility of claims. So the Center for Open Science was responsible for extracting research claims from the claim extraction set to be evaluated by other teams. And a first of many definitions that I'll say here, a claim in this context is referring to a specific or concrete finding that was supported by a statistically significant test result or otherwise comparable evidence. And we ended up with about 3,000, or claims from 3,900 papers, excuse me. We also coordinated hundreds of replication and reproduction projects with researchers from across the globe to provide that benchmark data that was then used to evaluate the accuracy of human and machine assessments. Some more definitions here. A replication in this context is testing whether evidence in support of the original finding could be found in a new sample of data. And a reproduction refers to repeating the same analysis using the original data to see if we could produce the original results or figures that were reported in the original paper. We started by assessing process reproducibility of the 600 papers of the evidence set. This was meant to see if a reproduction attempt could even be made, and we did this by checking if the original author ever shared the data in code. From there, we deliberately selected papers with the potential for multiple types of credibility evidence and that were as representative of fields as possible. In the end, we ended up with around 800 replication and reproduction outcomes from around 230 papers. PW, or the Jacobs Corporation, and the University of Melbourne used human evaluators to generate confidence scores that predicted the replicability or reproducibility of those 3,900 claims extracted from the claim extraction set. One more definition here, a confidence score in this context refers to a prediction about the replicability of a claim, which was expressed as a numerical value on a scale from not confident to very confident. These teams used a structured elicitation process known as the IDEA protocol, which stands for investigate, discuss, estimate, and aggregate, to complete group evaluations of these research claims. In step 1, investigate, participants would read the paper in the research claim and make a first round estimate prediction of a confidence score and the reasoning behind the estimate. Step 2, discuss. Participants would reveal their estimates and their reasoning, and a group discussion would ensue. Step 3, estimate. After the discussion, members would review the contents of the discussion and make a private revised estimate. And the last step, aggregate. They would mathematically aggregate all round 2 estimates into a single assessment of the credibility of a research claim. The machine assessments teams included Pennsylvania State University, 26 labs, and the University of Southern California. They used machine learning methods to each develop unique algorithms that assigned confidence scores in the same way that the human evaluators did. Pennsylvania State University used synthetic prediction markets for scoring the replicability of claims. 26 Labs developed a system known as the A+ system, which utilized parsing and information extraction methods that were then used to assess the replicability of a claim in a context-sensitive fashion. And the University of Southern California developed a system known as MacroScore, which was specifically developed to mimic the nuances of human judgment when reviewing a research claim. In all, this team made machine predictions of around 27,000 papers. SCORE was a massive undertaking and a widespread collaboration that investigated the potential for algorithms to assess the credibility of research claims at scale, a potential major innovation in research evaluation. This project produced a wealth of data, which is now being built upon by its successor project, SMART. So SMART, which stands for Scaling Machine Assessments of Research Trustworthiness, as mentioned, will build upon the research work that was initiated by the SCORE program through conducting user research and generating additional data to improve and expand the algorithm and human assessment approaches even more that were developed in the SCORE program. The first half of the SMART program focuses specifically on expanding the database of claims and using user research to improve the human and machine methods. Essentially, it's a pretty simple workflow that starts with collecting preprints or otherwise unpublished and unpeer-reviewed papers from participants. From there, the Center for Open Science will extract a single claim from each paper, which will undergo review by our human and machine assessment teams using all the same methods from the SCORE program. From there, the human and the machine assessment teams will each generate a report that details a little bit of their methods and the reasoning behind their confidence scores. And those two reports will each be sent back to the participant, who will also receive a user experience survey that will inquire about their experience with and their perception of those reports. From there, a subset of participants will be invited for a user research interview, which will aim to go a little more in depth on potential use cases, challenges, validity, etc., with those reports. The second half of the SMART initiative is an algorithm competition, which at this point in time is in its early planning stages. The main objectives of the competition are to diversify the types of algorithms that are used to predict replicability of claims or credibility of research more broadly. We also want to engage a broader community of algorithm research teams that are interested in advancing automated methods for assessing research credibility. We, of course, also want to increase the validity of algorithms and investigate the presence and the amelioration of biases in algorithms. And lastly, to establish a sustainable community of algorithm maintainers that continuously evaluate and improve algorithms as training and test evidence becomes more available. So I know it's easy to get lost in the granularity of these projects, but I want to zoom out and reiterate the intentions behind these studies to investigate one of many possible innovations in research evaluation. While SCORE and SMART explore potential supplements to already existing research evaluation, we're also investigating a more incremental innovation that is designed to work within a traditional peer review model, bringing us to our second project of discussion today, registered revisions. So another angle from which to address issues of research evaluation is the idea that the incentives in the current system for peer review encourage people to get published rather than to get it right, so to speak. Pre-commitment devices attempt to address those issues with incentives of peer review by enhancing planning, mitigating the pressure to achieve preferred or publishable results, which in turn can help mitigate questionable research practices or even publication-related biases, and by putting more focus of reviews on methods over results. Examples of pre-commitment devices include pre-registration, where you register your research question in your plan, or registered reports, which takes that a step further by submitting that registration plan for review. Once authors come to an agreement with reviewers, the journals give authors in principle acceptance, where after that, authors collect their data and do their analyses, write their manuscript, submit it back to the journal, which then reviews the manuscript based off of its adherence to the original approved research plan rather than the results. Registered revisions is a new kind of pre-commitment device that is also designed to address consequences of the traditional peer review model. Typically, reviewers can sometimes make a request for authors to add more data or additional analyses to their manuscript. At this point in time, authors are usually quite close to getting a publication, and that pressure can sometimes introduce an environment where questionable research practices slip in. There's also a level of uncertainty that sort of amplifies that environment where even if an author does submit more data or a great additional analysis, they can't tell if that will lead to a publication. To mitigate those concerns, authors could register those larger revisions before collecting the data or conducting a new analysis in the same way that one would in a registered report. In other words, after a reviewer makes a request for more data or an additional analysis, the authors would first submit a revision plan, which would undergo review, and then collect the data or conduct the additional analysis. From there, reviewers would review the new data or analysis according to its adherence to that revision plan rather than the results. In theory, registered revisions could decrease uncertainty in publication outcomes, where authors could have a little better of an understanding of how addressing a revision would affect the publication of their paper. It's likely to have some sort of effect on publication timelines. Ideally, it could shorten them by providing a little more structure to the review process. It could decrease publication-related biases and questionable research practices, and it could focus reviews on the strength and quality of the methods. Registered revisions are an innovation designed to improve peer review, but we don't have any knowledge on its true effects, and testing journal policies at this scale is certainly not easy. In order to accommodate for the real-world challenges of journal policy experimentation, which include obstacles with coordination, sample size, incentives, workload, and much more, a meta-analysis would really be the ideal situation that aligns with our objective of discovering the effects of registered revisions. It would be a many-study approach to evidence generation and policy change. It would be comprehensive, practical, even pragmatic, and it would present a new framework, certainly new challenges, as well as new opportunities. But the issue is the evidence that we would need for a meta-analysis does not exist. So we decided to attempt to organize the studies that would produce the evidence we needed, effectively conducting a meta-analysis in the reverse order. In this case, individual journals or journal consortia would each conduct a randomized control trial on the effects of registered revisions, and each journal would collaborate with each other and the Center for Open Science on the design, implementation, and analysis of their trials. In this way, the meta-analysis will sort of be centralized. As mentioned, each journal will be encouraged to consult with and collaborate with one another, and all of the randomized controlled trials will already be connected through the Center for Open Sciences organization. This design will generate shared experience, designs, and resources, aligned incentives, strong scientific inference, and practical applications. In order to make this work, the Center for Open Science is going to provide a study in a kit, which essentially will have all of the building blocks a journal needs to conduct a trial of this nature, including template protocols, data collection materials and infrastructure, a data analysis design, an IRB pathway and materials, and of course, implementation, design, and logistical support. On the journal side, each journal or journal consortia will conduct a randomized control trial on the effects of a registered revision policy, where each RCT is specific to the journal's unique requirements and needs, including with specific intervention policy design, schedules and timelines, and specific outcomes measured. And of course, each journal will have full ownership of their own publications, as well as authorship on COS-led publications. The individual study design itself is a simple two-armed trial where a paper would become eligible if it receives a peer review comment requesting one or more of the following: new data collection or new analysis of existing data. If found eligible and if the authors consent, they would be randomly assigned to one of two arms, either the standard review procedures, where the standard policy of that journal would be followed, or the registered revisions arm, where, when assigned, an author would first submit a revision plan. Editors and reviewers would review that plan before implementation, and if possible, grant that author in principle acceptance. Participants from both arms would both be followed up with a survey to inquire about their experience with and perception of either arm. So the primary outcome of this study is going to be time from paper review or revisions to final decisions. Again, we're very curious on how this kind of policy would affect timelines, if it makes it longer, if the process slows down at the end or starts slow. So that will be our primary outcome. Secondary outcomes will include measures of statistical significance or uncertainty, such as p-values, standard errors, and confidence intervals regarding the new data or analysis revisions. We're also curious about the proportion of articles that are accepted in either arm. We also want to know about journal and author subjective experience with the registered revisions policy, and of course, any other outcomes that are of interest to the journals. Current methods of research evaluation are imperfect. That's why we're all here today. In this presentation, we talked about two innovations to research evaluation at the Center for Open Science, but that's not all we're doing. We're also exploring other innovations, most currently the concept of a life cycle journal, which will be a new model of scholarly communication that aims for transparent, community-led, and continuous assessment of a research project from the conception of a research idea or proposal to its publication, with the goal of increasing open scholarship norms and production more broadly. The Life Cycle Journal, Registered Revisions, and SCORE and SMART are representative of new forms of research evaluation within individual pieces of research and the research process itself. And it's been an honor to talk about each with you guys today. Thank you.